Good evening, everyone, and welcome to SocialFlight Live. I'm Jeff Simon. We have a fantastic show for you this evening. Phil Lockwood is here. We are going to talk about the story of the AirCam aircraft, Rotax engines, his story, so much more. Cannot wait to get him. You are going to find he is a truly amazing individual. Before we get started, just a few things. First of all, even though it is cold outside and snowing in some parts of the country you wouldn't think are getting snow, aviation is booming. And in SocialFlight, we have tens of thousands of aviation events and destinations. We have all sorts of webinars and educational events like this evening's program that you can find. Just go to socialflight.com or get the free SocialFlight mobile app for Apple and Android devices. You can go in there, check out all those events and so many others to do. In addition to that, of course, we have our personalized adventure planner we call SocialFlight's Destination Digest and our FAA learning system. And that's great because you can go on there, take courses, get wings credit on your time and your schedule. And if you happen to be a mechanic, you can take part in the AMT Awards, Aviation Maintenance Technician Awards program. And also, if you are coming up on your IA renewal, as any of us that have IAs are, then you can actually get your continuing education for your IA renewal directly on SocialFlight, completely free. Get your certificates for your 8 hours of education. Just check it all out at socialflight.com. And lastly, we have our Fly to Win Challenge. That's right, you can win a Lightspeed Delta Zulu headset on February 1st. We already gave one away to John Southworth at Edmonton, Kentucky. He was a winner of our last prize. And now all you need is that mobile app. Check in and win. You can check in at your local airport, fly to numerous airports, get additional points. It's all great in terms of supporting General Aviation, getting you out there and flying. And if we can get you a free headset in the process, that amazing Delta Zulu, then we're happy to do that as well. Tonight's broadcast is brought to you by WhipAir and their amazing Whip line of floats. Their factory in South St. Paul, Minnesota is absolutely fantastic. If you have not had a chance to check that out, please, if you're flying anywhere nearby, go visit it, get a factory tour, see how all of that is done. They put together these floats, and it's like building an aircraft because some of them are as big as a hull as it would be on a regular aircraft, as the fuselage. It is spectacular. And in addition to that, you can see their factory and how they do things for avionics, for interiors, regular maintenance. It's all there. So check them out and be sure to thank WhipAir for supporting and making all of this possible. Now to tonight's guest. Phil Lockwood is the inventor of the AirCam aircraft and America's foremost expert on Rotax engines. His company, Lockwood Aviation Group, based in Sebring, Florida, includes the AirCam aircraft kit division, as well as aircraft supply and service divisions, a repair facility, and the Sebring Aviation Flight School. They even have a Rotax mechanics school for those of you who want to work on Rotax engines and learn how to do that properly. So whether it's parts, maintenance, aircraft, or just learning how to do it, it's all available at Lockwood Aviation. Be sure to check out all of that. Now, his leadership in aviation spans more than 30 years. After becoming known for his bush flying in the world of conservation and wildlife filmmaking, Phil was approached in the early 1990s by National Geographic to fly photography missions in the African Congo. Rather than fly an extremely dangerous mission, Phil Lockwood designed a completely unique and new aircraft, one that could get the job done safely, and in the process, he launched an amazing industry niche. The AirCam aircraft that he designed has become legendary for its capability and service in both commercial and recreational applications. AirCams serve around the world on either wheels or floats, and the original AirCam prototype flown for that Congo mission is now on display in the Aviation Museum at EAA headquarters in Oshkosh, Wisconsin. In addition to the AirCam, Phil is currently involved in developing a Rotax-powered RV-9 Vans aircraft that could very well become the standard for Vans designs for years to come. I am thrilled to have him with us tonight. Please welcome to SocialFlight Live, Phil Lockwood. Phil,
Hello.
how are you this evening?
Very good.
Thank you so much for joining us this evening. I have to say, My first opportunity that I met you in person was when you and I were in Houston, getting trained all about oils and learning the insides of that chemistry. And I thoroughly enjoyed getting to know you personally. And I'm just thrilled that it led to tonight's broadcast.
Yeah, well, that's thank you very much, and I appreciate you having me on your show.
So
I don't
I'd
know if I
like
could
to.
get to that intro though.
Oh, that don't protest too much. You deserve every single line of it and far more. I'd like to take folks back to the beginning for the folks that don't know your personal story of how you became the Phil Lockwood everybody knows today. I mean, I said a little bit in the intro, of course, that you were involved in aviation and wildlife and conservation photography, but your aviation story started before that. So take me back a little bit and fill me in on how you got connected to aviation and capable of designing an aircraft.
Well, I don't know how far back we want to go, but when I was a kid, we used to vacation in the Adirondack Mountains on Fourth Lake up there and on the Fulton Chain. Beautiful area. I still go up there in the summers with my family in June. Love it up there. But this would have been in the 70s. My dad managed to organize a seaplane flight for my brothers and I, and that was pretty cool. So I think it would have been a Cessna 206 on floats, taxied up to the dock at the resort, the camp we were staying at, and so my two brothers and I climbed in. I got to sit in the front right seat because I was the oldest. So. And then a couple of other kids from the camp went along too. So I think we had all 6 seats filled. And I did a lot of boating as a kid. Really enjoyed the water and boating. And when that plane taxied out and then he brought it up on the step, I could see the floats planing. That was very cool. And then rotated for takeoff and then flying around the area. And then I got to see the lake. Now back then, that lake wasn't marked very well, and it had a lot of shallow spots and rocks and hazards. And I could see all the shallow areas because the water was so clear on Fourth Lake back then. And to see that from the air really made a big impression on me. And I memorized all those shallow. Oh, look at there's a shoal there. There's a rock pile there. And it was so cool. So then came back and that I think that just made a lasting impression on me. And when it was time to decide what I was going to do, when I got out of high school, I decided to go into aviation and applied to FIT. I liked their program; it looked pretty good, and spent 4 years there, and got all my flight ratings and an aviation business degree, and that was my foundation.
That is very cool. Tell me a little bit about what you remember of learning how to fly there and progressing through those ratings.
I remember my first instructor pretty well. I think he was pretty good, and we were flying in Cherokee 140s, and I really enjoyed it a lot. Just right from the get-go, it was a lot of fun for me. I think I had about 10 hours when I soloed, and it was in Melbourne there. I think I was like runway 22, I believe, and it was perfect. It was great, and just from that point on, I never looked back.
Did you
Uh,
did you feel like you were kind of a natural? Did you feel connected to the plane from the beginning? Some people kind of struggle with that. Some people like the science of it. Or was it just natural?
the flying part was pretty easy for me. You know, I I kind of have a knack for working with mechanical things, whether it's a boat or an airplane. I can see and understand things that maybe aren't so natural for other people, whether it's docking a boat in a crosswind or a current, and compensating for that, and knowing which way the rear end's going to kick or the stern's going to kick when you put it in reverse, and being able to use that to your advantage. Flying there's a lot in common there, and I had a lot of time in boats. I worked at a marina as a kid in high school, and I think that might help. But yeah, the flying part was easy for
It
me.
does.
It was Studying was harder. The flying was easy.
It does seem like there's a big connection when you start talking about marine and aviation. Obviously, there's a historical connection. There's terminology that's connected there, but It is very interesting, and we've had folks recently on the show that have been very connected to seaplane flying in particular, which I know you are. And when you listen to like John Nordstrom talk about flying the Beaver, or Kenny G talk about it, what's connected to doing that, it seems like I'm not a seaplane pilot, but there's this almost zone that you guys go into when you talk about that connection you just made between knowing how currents work and how the wind works, and it just connects to flying perfectly.
Yeah, it's a great combination of, flying floats and an airplane, boat and airplane together. And that, I think if you're good at one, you can be good at the other. Like landing an airplane in a crosswind, it's something that you learn, and you just have, if you have a natural knack for making that compensation, doing a dead stick landing, looking and saying, I want to touch down right there. And how do you make all that happen? Your brain just does it, and you end up where you want to be, right? So that's something that some people, it comes easy to, and other people really have to work at it.
Yeah, it does seem very similar to pulling that boat into the slip just perfectly, and not bumping anything or reaching the dock. So tell me a little bit about then how you, after college and after getting your ratings, what got you involved in conservation and wildlife flying?
So I always enjoyed photography. I always had a good eye for light, and my dad was an engineer, and he was a good photographer, and he taught me how to use a camera. He taught me how to work exposure. He taught me about depth of field and how aperture affects that, and how shutter speed works. And I got my first camera as a young kid. It was a 35 millimeter camera, and it was fully manual. And I had to learn how to expose by trial and error. I knew that, if you had 100 speed film, and you were at 1/25th of a second and f8 or f16 on a pretty sunny day, that was going to work. And then from there, you would work it with either lower shutter speed, more shutter speed, aperture. And I got pretty good at that. And then I had a light meter, and then, man, I graduated and actually had a Pentax K1000 with a light meter built in it. Wow, that was pretty cool. But I got pretty good at photography. Did a lot of photography in college, and always enjoyed wildlife. And when I got the chance to fly for some of these National Geographic guys, and some of the Survival Anglia people, and BBC, and different groups, these guys were really, really great people. They were very dedicated, very devoted, and they were always trying to get that great shot, or that great little bit of film. And back then I was working for a company called Max Air, flying and promoting an ultralight called the Drifter. And it was similar to the AirCams, kind of where I got that idea of being what it's like to be out in front of the plane. And it was a pusher, single engine pusher. And so that plane kind of brought a lot of these people to me, because the front seat was such a good camera platform. So I remember one guy actually went to Quicksilver, and one of their people, when he showed him what he was trying to do, he said, "Man, you need to go fly a Drifter." I couldn't believe it when he did that. But anyway, the industry was pretty tight-knit back then, and we did have the ideal plane for what he wanted to do. So then got the Bartletts involved. They were a couple from Australia, who were working in Namibia, in the Namib Desert, and they did a bunch of really cool specials. But they needed an aerial platform. Got the first Drifter. I actually ended up teaching Jen how to fly the Drifter. Then she later came back to our flight school and got her pilot's license with one of our instructors. But I taught her how to fly the Drifter, and ended up making several trips to Namibia to help them with the planes. Went over and finished putting them together when we shipped them over disassembled. And I just had a hell of a lot of fun. They had all this great equipment. They had 16 millimeter film cameras, Ariflex, They had Leica 35 millimeter cameras. They had, medium format cameras. They had tons of lenses, and they were really good. And so I was just soaking it all up and learning about how to shoot with them and flying for them. And so that was the start. And but in the desert, you could land almost anywhere. So a single engine airplane, was appropriate for low flying. It was pretty reasonable risk. Um, but later, a group that was working on a project in the Congo over the Ndoki rainforest came to me, and they wanted to do the same thing. And they showed me where they wanted to fly. And so I said, well, like, you're over the forest like all the time? Oh yeah, all the time, except when we come back to land. I'm like, so what are the chances of rescue if we go down? There's no chance of rescue. No. I'm like, I don't know if that's such a great idea. I was past 30 at that point, and I knew that nobody's indestructible. So, and I'd had engine failures, and I'd always managed to find a place to put it down safely, and I wanted to keep it that way. So anyway, I'd been working on this concept of the twin engine AirCam for that purpose, not for the Congo, but because these guys always wanted to fly low over unlandable stuff. And I would look at it and I would say, okay, if we go down and make a low pass over that marsh or over those trees or over that river, we're going to be down there for about 2 minutes, and then we can be back up to 2,000 feet, and then I can make that field or I can make that field. And I would say, well, that's the risk we're going to take. And I got my engine maintained as well as I can. The airplane's in good shape, and so we're going to accept that 2-minute risk. But the Ndoki rainforest was a different deal. It was like all the time. It wasn't 2 or 3 minutes at a shot. So yeah, I showed them the drawings that I'd made, and they said, well, build the first one for us. It was kind of crazy, really. When can you have it flying? And I'm thinking, maybe when do you need it? And they told me this was in the spring and they needed it in the fall, 6 months. And I'm like, yeah, I guess we can do that. Well, I mean, that was crazy. That was impossible. But I didn't know that at the time. So I accepted the offer to build the first one for them. And we built it in 6 months from scratch, made every part, built the whole damn thing, designed it, built it. I managed to bring in some good people to help me with it, and yeah, it was pretty. It was 7 days a week. It was pretty radical what we were doing. It was a lot of fun, and I remember, I kind of guessed at the wing spar sleeves and diameters, and I thought I was going to be pretty close, and we got the prototype flying. And I'd hired a couple of engineers from Embry-Riddle, and they were banging out calculations. And I was on my first mission in the Congo making the flights when they were doing the load testing on the wing. And I got a satellite call somehow came through, and they said, "Hey, we passed the load test." I'm like, "Oh, it's damn good to know."
Yeah.
So
since you're already over the forest.
Oh yeah, I was already flying it, and so yeah, it was fun times. And then when we finished, I made a couple of trips flying for them out there, and it went pretty well. Worked pretty well. We were flying out of a 600-foot strip, one way in, one way out over the Songa River, and I could actually touch down on the very end of the strip, coming in over the river, and shut the engines off and drift and coast to a stop without the brakes. In that 600 foot. So if I put it right on the end of the runway, and I know that because the second time I came out there, the brake reservoir had cracked and all the brake fluid ran out, and we didn't have any spare brake fluid. So I had to do that until we managed to get it fixed.
Wow. And I'm just absolutely flabbergasted by that. I mean, so you had never built an aircraft before, certainly not designed one, is that correct?
No, I hadn't, but the time I spent with Max Air, I got pretty involved in the development of the two-seat drifter, because when I came on, they just had the single-seater, and flying it and tuning the flying controls, and then I got to design the aerobatic version called the Rocket, which was a lot of fun, and so I was able to pick it up and figure it out and do it. And so a lot of the same construction techniques were used on that first AirCam, things
Wow.
that I had learned in building the drifters. And I didn't design the drifter. That was a guy by the name of Roy Pinner, and then Dennis Franklin is the guy who put it in production. And it was based on a Klaus Hill design. But I did make the aerobatic version called the Rocket, and yeah, that was a fun machine.
I'm gonna have to look up the Rocket because I was not aware there was an aerobatic version of the ultralight drifter. You don't usually think of ultralights as being aerobatic.
Yep, it had a short, I think it was a 23-foot wing, full span aileron, steeper ailerons. It had a 532 Rotax on it, and it would do about 100 miles an hour straight and level, and I could loop it from straight and level flight and not lose any altitude. I'd come right back exactly where I started, and I did snap rolls with it, and it was fun. It was really cool. It was fast roll rate. And when we did the load testing on it, I remember we got to 10 Gs, and the engineer that we were working with said, "Okay, you're done. You don't need to go on. That's good enough."
It's beyond what'll break the pilot.
Yeah, we never did. We never did fail it. But yeah, that was we didn't build many of them because it was kind of an exciting airplane that sucked a lot of people in, but then they ended up buying the two-seater. So.
That is very cool. So you mentioned obviously 532s and then 582 Rotax engines. Tell me a little bit about your experience with Rotax, because did it start, of course, back there at Max Air when you really started getting exposure to it, and what's it been like watching the evolution of that engine?
It was very interesting. So when I got into the ultralight industry, not long after I graduated from FIT, and I was looking at the aviation industry, figuring out what I wanted to do. Do I want to go to the airlines? Do I want to go into the Air Force? That was another option I was looking at, because I had the 4-year degree, so I could go become an officer in the Air Force, and I was very interested. I was very close to pulling the trigger on that. The appeal of flying fighters was pretty strong. Or do I want to work in the industry? And I thought, well, I got till I'm 25 to decide. The Air Force will take me to 25. So once I pull that trigger, I can't turn back. So I think I'm going to play in the industry for just a little bit and see how I like that first. And the ultralight industry was in a boom at that time. And it, it seemed like it needed there was room for some professionalism and maybe some opportunities, and the planes looked grassroots and fun to fly. So I saw the Max Air was building the Hummer, and they just come out with the single seat drifter, and it looked pretty cool. So I applied, and they were looking for a sales person, and I went down and interviewed with them, and they ended up hiring me, and it was great. Dennis Franklin, the guy's a genius when it comes to manufacturing, and he was making parts for the whole ultralight industry. He had a Boyd injection molding machine. He was a tool and die maker. He figured out how to manufacture all this stuff, and made these tube duplicating machines where you could drill holes simultaneously in a tube with a mechanical machine and reproduce the spars really quickly and easily. And I learned a lot from him. I enjoyed working with him. Great. He was just a super guy, and he ran a pretty good company back then. So we came up with a two-seat drifter. The guy who was in charge of their marketing ended up leaving the company. I took over after like a year, as became their director of sales and marketing. And yeah, it was just I got to know the industry, work with the magazines, do their brochures, write their flight training manual, uh, and set up the dealer network, and everything, run the shows. And I was just learning at just a huge rate. I was with them for like 5 years, and then ended up deciding to start my own business, and that was the beginning of Lockwood Aviation. But what I saw, I got to work with a number of different two-stroke engines, and Rotax was just coming on the scene when I got in there. And we had the 277 and the 503, and then the 377, and then they replaced that with the 447. And we had the Kiyunas, we had Sonoas, we had Kawasaki's, we had all these different two-stroke engines that were being used. But it became clear to me very quickly that Rotax was the best. They were not the first, but they quickly became number one, and it was because they had the best engines. They had the best engines, and then they decided to add a gearbox to them, which was a big step forward. And they had a lot of history as a gearbox manufacturing company, and so that's why there's the gear, I think, in the BRP thing. Logo was part of their history there. And they came up with exhaust systems that were just for those engines, and different configurations that would work on a pusher or a tractor. So packages, basically engine packages. And then they optimized the port timing for low-end torque and to make them live longer and turn the prop better. And they came out with dual electronic ignition. And anyway, they just took over the market. And I got to work with some of the competitors. They weren't as good. But what I noticed in the beginning was we did not know when to service the engines. We changed the plugs once in a while, but basically we ran them till they blew up, and that was going to happen at some point, but you had no idea when it was going to be. And so I kind of thought, we need to make these engines more reliable, and we need to do it with maintenance. And so I started the Rotax Service Center in Florida. That was around 1990, and there were a bunch of service centers at that time, and we helped develop service techniques, and then we got to the point where we knew how to make those engines run reliably. Like you tear it down at this point, and with a two-stroke, you don't wait until it blows up. It doesn't fail nicely like a four-stroke often will. It just fails catastrophically, and so you have to go with conservative overhaul times and maintenance schedules, and then you can make them run reliably.
And did Rotax provide any of that kind of guidance and data, or did you figure out where you needed to put the TBO type times and the inspection times on those engines?
Well, we were figuring out what oils work, because the Rotax had a unique dike ring that packed carbon, and they would stick. And so you could have one two-stroke oil that might really seem to be a good oil, and it would stick the rings in 25 hours. And then you use a different oil, and they might go 300 hours without sticking the rings. So huge difference from one oil to the other. And so I spent a lot of time testing we were overhauling engines in our shop pretty regularly, and you could see the difference. I'd say, what kind of oil are you guys running? What kind of fuel are you running? And then I could see, oh, the rings are stuck, they're not stuck. How many hours do you have? What kind of wear do we see? And we realized pretty quickly that an air-cooled two-stroke oil was going to be the best way to go, and started working with Pennzoil back then, and yeah, they came up with the best oil. I think Rotax set the 300-hour TBO eventually, and then we promoted that.
Tell me about the introduction of the four strokes.
So the first 80 horsepower 912 came out in 1989. Rotax had been working on it for a while. So right as I was getting my service center set up, the 9 series was just coming out. I went to the first training course that was up at Ron Shetler's place in British Columbia, in Vernon. that Eric Tucker taught way back then. It was around 89 or 90 when I went to that school. And that was the beginning of the 9 series. So they basically, it was an 80 horsepower engine, worked very well, but the power to weight ratio was pretty good for the time, but it was kind of similar to a 582. You know, if you looked at the power to weight ratio, 80 horsepower for a 912, 65 horsepower for a 582, the power to weight ratio was similar. So if you wanted the extra efficiency, about 25% more efficient, the 912 would be worth it. If you wanted the longer time between overhauls, the 912 would be worth it. But if you just were looking at pure performance, it wasn't going to be that much different in a lightweight airplane. So on the AirCam, the 582s were still the way to go. Back then, the 912 80 horse didn't really do much for single engine performance. And then they found out they could get a lot more power out of it if they turbocharged it. So the next one they came out with was called the 914, and that was a turbocharged version of the 80 horsepower engine at 115 horsepower. Now that had a pretty good power to weight ratio. So we put those on the AirCam. That was the first 4-stroke that we put on the AirCam, and it worked pretty well. But it was maybe a little more complexity than you might really need, but the airplane carried it well, and we had good single engine performance. And then the next one they came out with is a 100 horse 912 ULS, and that one was interesting because basically they took an 80 horse and they big bored it, which is what people are doing to the 100 today, right? They upped the displacement, and they changed the cam, and they upped the compression ratio so it wouldn't run on 87 anymore. It needed 80 or 91 octane premium auto gas, and they got 100 horse out of it. And then boom, now it weighs the same as an 80. So now you got power to weight ratio, and that became the engine for the AirCam. That became the most popular engine for the AirCam.
Wow. You know, one of the things that's interesting about that is you mentioned gearboxes. What is it about the Rotax gearbox that makes it so reliable? And why do you think other gearboxes throughout experimental aviation have not been, they've paled in comparison? They've never really been successful.
Well, Rotax had a lot of experience manufacturing gearboxes, I believe, from their early days, and so yeah, they were able to design for the 2-strokes. It was the same issue. I mean, in the 2-strokes, when other companies started putting gearboxes on 2-strokes, they were failing. And I mean, I saw people take a planetary gearbox that was designed for a 300 horsepower V8 and put it on a little 2-stroke, and it would destroy it.
Really?
Well, it would destroy it. Yeah, it just the torsional vibration was so fierce. So Rotax recognized that, and they came up with torsional vibration dampers that they built into their gearboxes that took that shock out and saved the gear set, and that's what made them work. Some of them were rubber coupling, like in the C and E drives. Some of them were mechanical torsional dampers, like in the B drive on the 2-strokes, and then in the 912 gearboxes. Now the latest gearboxes, I think, are a big leap forward in technology and in probably long-term maintenance that they're using on the 915 and the 916. That uses a torsion bar to absorb the torsional vibration, and that's a pretty slick setup. It's really complex inside. Like, don't tear one of those apart unless you know what you're doing, because you're not going to be able to put it back together again, or you're not going to put it back together correctly.
Can you explain a torsion bar to the viewers?
Do it. Say what?
Can you explain the torsion bar concept to the viewers?
Sure. Well, it'd be a steel shaft that twists, and so within the gearbox there is a steel shaft that is designed to absorb torsional vibration. So it actually is twisting back and forth a lot on startup, and then during operation always a little bit. So it takes the load off from the gears. Any engine's going to have torsional vibration. Obviously, an inline six is going to have less. A V12 is going to be even smoother. But a four-cylinder engine, every time you have a power stroke, there's an acceleration that takes place in the crankshaft at that moment. Boom, and so that puts a load on the gearbox, and then you go into a compression cycle where you're compressing the next fuel air mixture, and so it's slowing down and it's using its momentum in the flywheel to get it through that next cycle, and then boom, that explodes, and now you have another power cycle. So it's slowing down, speeding up, slowing down, speeding up all the time. Those changes in crankshaft speed are exaggerated at idle and on startup, and they're particularly hard on the gear set. So you have to have something that can absorb those, and that's what Rotax has figured out how to do. One of the things they figured out how to do to save the gears.
That's really impressive. And again, they seem to be the only ones that have been successful doing that, because automotive conversions for the experimental aviation market, or even the certified aircraft market, it seems that gearboxes have always been the reason that those can't succeed.
It's one of the reasons that they have a hard time. But no car engine is designed to be an airplane engine. I mean, they convert them, but when you think about what you're requiring of an aircraft engine, it's really difficult.
Mm.
So first off, it has to be very light, and aircraft engines, the Rotax 9 series engines, are lighter than any car engine that you're going to convert to start with. But then you want to be able to run it at wide open throttle or close to all the time.
Mm.
So, I mean, a car engine is just not designed to operate that way. I mean, if you go wide open in most cars today, you're beyond the speed limit in 6 to 10 seconds, and then you just can't do it. I mean, you've got to back out of it. Unless you're running on the Autobahn or on a racetrack, you're not going to run that thing wide open very long.
Right.
You're going to be at, what, I don't know, 20% power, 15% power, very low power settings typically when you're cruising in a car. Airplane's not like that. You are running them hard. I mean, I have a lot of customers that will run a 912 wide open all the time.
Mm.
I mean, they prop them for 5,500, which is max continuous allowable, and they just cruise wide open. And
Wow.
and those engines they'll go 2,000 hours like that.
Well, that's the thing. I mean, you don't hear really much about problems with the Rotax four-stroke engine series. Do you think that they are more reliable than traditional aircraft engines, or is it just that we don't see and hear as much about it because it's experimental? What do you attribute that reputation to?
Well, I think they're pretty darn reliable. I mean, you can't say that a well-maintained Lycoming or Continental is not a pretty reliable engine also.
Oh, they are.
So, but I think the Rotax engines are right up there. I mean, if they're maintained properly, they are very reliable, the 9 series engines. So, I mean, they're well-designed, well-tested engines. The thing about the Rotaxes that is hard to deal with is that they're in so many different airframes, and like any installation, the installation is important. So a lot of times when we see problems, it's because the installation probably wasn't done quite the way it should have been. I mean, the engine's running too hot, or what, the exhaust system isn't mounted properly and it's cracking, or on and on and on, different things. The oil tank is mounted too low.
Accessories, mounting.
They just think it's like in the installation manual, it tells you how to do it. Come on. But no, generally they, it's amazing to me how many people I see that do like everything wrong and they still don't have any problems. I mean, it really is amazing sometimes.
Yeah, it's really impressive, and that kind of brings us to where we are now with the miracle engines of the 915, 916. Tell me about that.
Yeah, the 916 really is a miracle engine. It is an incredible effort, I think. Super high power to weight ratio. It's smooth. It's incredibly efficient. 160 horsepower power output, and they've achieved a 2,000-hour TBO right out of the gate with that engine, and they're pushing it hard. And they're backing that up in the U.S. with a 5-year, 2,000-hour warranty, which means they're standing behind that engine. And I've been running it in an RV-9 that we've been playing with because we've been developing the firewall forward package for that airplane with vans, and it's very impressive. I mean, that plane is so fast with that engine, and it's so smooth and it's so efficient. Yeah, every time I fly it, I'm amazed.
So I'm going to show because we've got that's the big project that you've got going on here, and it is impressive. And just for comparison purposes here, talk us through the traditional aircraft on the left and the Lockwood Aviation version on the right.
Yeah, so obviously the 916 is a lot lighter than a Lycoming 0320, which is what most people put in the RV-9. So we had to move it forward quite a bit. Now we got some pushback from vans on that because they like their short nose, which is what they're used to on the RVs. And there was also a chance that we might have some stability issues. So, but I was not going to do the package and add weight or deal with or have a CG problem. And so we could have shortened the nose, and we would have had a very limited CG. You wouldn't have been able to put much in the baggage compartment. You'd have to be very careful. Or we could add lead or other weight up front. I just didn't want to do any of that. So we decided we're either going to put the engine where it needs to be to balance the airplane properly, or we're not going to do it. And so that's what we did. And the first time around, we did have some pitch stability issues with the longer nose. And we thought long and hard, are we going to take another crack at it? Because we might not be successful. And we decided to take another stab at it. And so we did a whole new design based on what we learned from the first iteration. And we changed the shape completely, rounded the top of the cowling more, and solved the problem. So we also ended up adding that dorsal fin on the back, which most airplanes have. If you don't know what a typical RV looks like and you see it, it looks normal because, I mean, I think 90% of airplanes out there have a dorsal fin.
I didn't even notice that.
Yeah, I mean, it looks pretty normal, right? But we had a situation. Actually, Ryan, the chief engineer at Vans, was flying it with me, and he's the one that picked up on it. If you slipped or skidded the airplane, it snapped back to center. Absolutely, it was perfect. It appeared to have extremely good yaw stability without that dorsal fin on there. But Ryan, being the guy he is, decided to bury the rudder pedal all the way to the floorboard and just do a full all-on slip as hard as he could. And it went neutral at that point. And he's like, "Whoa, it's not, shouldn't do that." And I'm like, "Do what?" And he, I tried, and oh yeah, okay, that's interesting. So anyway, that problem was solved with the dorsal fin, and now it's just rock solid yaw stability no matter what you do. But
what do you mean it went neutral?
I mean, you could it would feel normal until you got to almost full rudder in a skid, and then it would stay there.
Oh,
it would go
it would
neutral.
stay.
It would just stay. Yeah, it was like, well, you just push on the other rudder pedal and come right back, but it'd be like, that's not good. We don't want that. So something was happening with the flow of the air around the cowling. But when we put the dorsal fin on there, boom, that was it.
You know what's amazing is with the longer nose, I actually think aesthetically that dorsal fin really fits. I think it helps the lines of the aircraft.
Yeah, we think it looks good. I mean, the plane looks faster, course, it is faster, but it looks faster, and I mean, most people seem to really like it. You don't feel it in the airplane. I mean, the airplane flies and handles perfectly. So you really, you when you're in the airplane, you don't even see the engine out there. You don't see the longer nose, and it feels, except I think it's smoother than the typical Lycoming. It's like a turbine out there with that MT3 blade prop. So you don't even know it's out there, but the performance is amazing, and the fact that it has full FADEC controlled mixture is also pretty nice, because if you're going to fly high and you want to be efficient, particularly if you're going to go lean a peak, it's a real pain in the butt to be constantly having to adjust your mixture as you change altitude, and you almost can't do it in the climb. I mean, you're usually a little rich in the climb. With this thing, like I get off the ground, I'm 500, 1,000 feet, and I go into eco mode, lean a peak, and then I just leave it there. And I'll climb all the way to, I can climb all the way to 19,000 feet, and that power setting remains constant. My climb rate remains constant. I can be doing 120 knots indicated, which will quickly turn into 140 knots true, and I'll just cruise right on up to whatever, 19,000 feet at that with that setting, and you're burning 8.5 to 8.8 gallons an hour, and everything stays the same, and the mixture's totally controlled for you.
So there's just a switch for the eco mode that puts it into lean a peak?
No, it's a slight power reduction. The engine knows if you take off power is 5,800, and then you come back to 5,500, which is maximum continuous. You can leave it there at wide open throttle if you want, and then you pull the throttle position back below 98%, and that's not 98% power, but 98% throttle position. I don't know how the computer sees that, but that's what it's looking at. And then it just goes into eco mode, and you'll see your fuel burn go from like 10.5 down to 8.5. Boom, just like that.
Wow, that's interesting. I'm trying to wrap my head around that, it being a throttle position thing, because you would think, especially at high altitudes where you're not able to really, unless it's completely turbo normalized all the way up.
It's boosting. It's boosting. It's going lean a peak in with pretty good amount of boost.
Wow.
Yeah, and they've got it figured out. So it knows what combination of RPM and boost is going to be safe, and so it just does it for you. And if it needs to go back into power mode, it'll do it. You can run in power mode if you want. You'll get a little more speed, not a lot, but you burn a fair bit more fuel.
Those numbers, though, are unbelievable. I mean, I believe you had mentioned 190 knots at altitude at 8.5, roughly, just over 8.5, a little bit more. That's really amazing. That's fairly unheard of in aviation. And if you want to run in more economy or more traditional RV-9 speeds of 145 knots, and you're down at like 4.5 gallons an hour.
Yeah, I can beat 145 knots on 4.5 gallons an hour at that altitude. Yeah, it's extremely efficient, and the gear's down all the time. I mean, it's a fixed gear airplane, and it's going that fast, and it's easy to fly, and it's got a super low stall speed, really effective flaps. And with that 3-blade prop, I mean, it's so easy to bring it down. I come screaming into the pattern. I'll be descending, at speed, and get slightly below your glide path, and then bring the power back and pull the nose up to get back on glide path and get down to flap speed and drop the flaps. So you can really make time coming into the airport, and then at the last minute slow it down quite easily. That prop, the 3-blade prop, will slow you down, and then the flaps, and now you're at 65 knots coming in.
Wow. So what's the status of the program, and for people who are interested in looking at this, of course, this is just the first aircraft, but at doing the RV-9 with your 916 conversion?
Well, we're taking orders. We expect to deliver the first kits March, April, right in there. Yeah, we're in the process of getting everything tooled and finalized. I think we've got about 160 hours of test flying time now. So we're coming down the home stretch.
Wow. Do you obviously, one downside is that Rotax engines have kind of climbed in price. Not that everything else hasn't, and aviation engines certainly have. But still, for an ultimate budget, do you see the price coming down over time for some of these newer engines?
I don't see the price coming down, unfortunately. I mean, everything, hopefully they won't go up much very fast. I mean, but yeah, you don't see many prices coming down. I think we're still very competitive when you compare with, Lycoming or Continental. Particularly the 100 horse 912 IS. I mean, 912 is just a little over $20,000 for a brand new engine. It's
Yeah,
pretty
that's
cheap.
a great. That makes a lot of sense. But isn't it? What's the 916 at now?
The 916, I believe, is just over 52,000, I believe.
Yeah, that's what I was referring to. I think certainly the 912 series is.
Yeah, you get into the high technology and that warranty is included in that, and then you have, they give you a Bose headset and a 30 headset with it. Yeah, it's worth something, right? But it's still a lot of engine for that kind of money.
Yeah.
It's still a lot of engine for that kind of money. So it's not going to be a cheap package, but when you look at what that plane is capable of, what you can buy and build an RV-9 kit for with this engine package, you can still have a very fast, very easy to fly, very easy to maintain airplane for not a lot of money. I mean, we're living in a world where a 172 costs what, so 680,000 or something like
Yeah,
that.
something ridiculous.
You gotta be realistic and make, it's all relative, but it's still very affordable.
Absolutely. That makes a lot of sense. So what do you see as the future, both for this conversion and doing more of them for other aircraft, and then also for the Rotax line?
Rotax is going great guns. I mean, they're still developing more engines as we speak, and I think they're going to fill up their line and just continue innovating. And I think they will build larger engines. There's no question that is on their agenda. I don't know where they'll land first, but I know they're looking in the 180 to 300 horsepower range, and
Wow.
they will build larger engines.
Do you think that we'll be looking in the near or reasonable future into conversions of existing certified aircraft to Rotax engines?
If you look at the light sport industry today, I think about 80% of the aircraft use Rotax, maybe more than. They really dominated that, and just like in the era of ultralights, a lot of these airplanes were designed around the engine. The best ones, they were designed around the engine, because when you look at an aircraft design, the weight of the engine and the power of the engine is going to determine the way the airframe is built. And so a lot of the light sports that are out there, at 13, 20 gross, they just could not be what they are without the Rotax engine. The RV-12, we're talking about vans. I mean, that plane, it has a good useful load with 13, 20 gross. It couldn't do what it does without the lightweight 912 as its power plant. So, Jeff, the best airplanes to come are going to be planes that are designed around the Rotax engines. If you look at the Sling TSI, what that does with a 915 or a 916 engine, a four-place airplane. It's got a big useful load. It's fast. It it performs really well with the 915 or the 916 engine. It was designed around those engines.
Yeah.
Converting is difficult, and this, even though this airplane was built around the RV-9 around a smaller, lighter engine, we still had to push that engine way out there to balance it properly. And in this one, it worked, but Vans had already done some of the work for us, right? They'd already narrowed the chord and moved the wing back. The leading edge, they kept the trailing edge where it was would be on a 6 or a 7, and they moved the leading edge back. So they had kind of designed this airplane with a lighter engine in mind.
Mm.
And that really helped make it work. But it can be difficult to take a lightweight engine and put it on an airframe that was designed for a heavier engine.
Right.
So I'd love to put two 916s on a twin Comanche. I mean,
Yeah.
That'd be very cool. But I think what you'll really see is you'll see new airframes designed around these Rotax engines that are going to be very cool.
Yeah, so basically, even as Rotax starts evolving to higher and higher horsepower engines that seem to many of us kind of out there like, oh, that number sounds awfully familiar to all of these Lycoming numbers or something like that. Like, could we do conversions? That the future really is, as you mentioned, nope, it's actually that you're going to see some amazing new aircraft come out, not so much that this older mentality we've always had of we can keep the old fleet going and make it somehow something else.
Well, you'll be able to convert a lot of them like we did, by pushing the engine out and doing that sort of thing. But I mean, again, we had the 9 was kind of built for a lighter engine, so it made it easier to do it and it really works well. But in some airplanes, I think the bigger the power, the greater the difference there will be between the weight of the Rotax and the weight of the engine it's trying to replace. And so again, you can just do so much more with an airframe design if you know you're starting with a lightweight engine and you balance the whole thing around that. If you look at, again, we're talking about RVs, so I don't want to just talk, but there's a lot of great Rotax powered airplanes out there. But if you look at the 12, they knew they were going to use that engine, and they were able to move the seat forward. So when you look at where you sit in an RV-12 compared to other RVs, you're sitting on the front of the wing. They
Right.
move you forward,
Yeah.
and your passenger forward to take advantage of that lightweight engine to give you better visibility. So you're kind of looking beyond the wing in an RV-12, and they move the engine back. And they crunched it all together, and they were able to keep the weight down and take advantage of that lightweight engine. So that's what you're going to see, I think, in a lot of designs in the future, is people taking advantage of lightweight. I hope Rotax doesn't decide to make their engines heavier, because they get a lot of complaints right now. The engine's too light, we can't use it. Oh, come on. And so they're probably going to be pushed to maybe not worry about weight so much, because they know that it does make it harder to retrofit. But I hope they continue to build the engines as light as they can, like the 916, and then just wait it out, because people will design airplanes around them.
Man, I hope that's true too, because I'd rather see ballast added than start getting sloppy with engine design just because people don't care about weight.
It's an interesting problem though, and they've got it right now with the 916. I mean, it's like, yeah, we can't use that engine, it's too light. I mean, oh, really?
Nope. Time
Great.
to design a baggage compartment for the front.
Yeah.
Wow,
Yeah.
that is very interesting. So tell me, you've got for Lockwood Aviation, for what's happening in your group of companies. We've certainly talked about what you've got going on in the past, and then of course the RV and what's happening now with all these different. But what's next? What's next for you guys? What's on the horizon?
Well, we want to get this firewall forward package out. We're very excited about it, and so that is the next thing that will be going out. We'll start shipping those those kits. And then we'll be back on AirCam development, and we intend to continue to develop the AirCam. So that'll, I think that's going to be exciting. Of course, we do have our little flight school, Sebring Aviation, and we do offer that multi-C rating, which is kind of cool. A lot of people come to our facility in Sebring and take the multi-C training and actually get their multi-engine seaplane rating with us in an AirCam.
That's so amazing. I mean, multi-engine seaplane, that is not a common thing. You can find a few ones with photos out there on the internet, but aside from that, you are not going to see one at any local airport of yours that you can go rent and learn how to fly.
It's pretty rare, and that's why the FAA decided to make an exception for us with that LOTA.
Wow.
And allow us to do the multi-C training. And it's, normally it's just transition training checkouts. So we're very fortunate to have that. And yeah, people are taking advantage of it and enjoying it and getting good training.
Yeah.
Yep.
It is really fantastic. And for anyone who hasn't seen what an AirCam can do, go do a search out there and take a look at a video of an AirCam taking off from the water on one engine. Something you can't usually do in a regular land-based twin.
Yeah, well, it's that big wing and the high power to weight ratio, but it does have to be a lightweight AirCam. And I know when I shot that video, there was nothing special about it. There was no trickery, but it was a lightweight AirCam, and we did have the Murphy floats, 1800 amphibious floats. Yeah. And I think it was a 180-pound guy in the back and me and half fuel. And so, yeah, and it was a warm day.
Absolutely fantastic.
Taking that plane to take off on one engine.
Well, Phil, we've reached a time of the show that we like to do something called SocialFlight's Fast Five to learn a little bit more about you in a quick question format. Are you up for that?
Sure.
All right, Phil Lockwood, this is your SocialFlight's Fast Five, and we're going to start with a question having to do with all these different aircraft that you've flown, because going all the way back, you did your training in different aircraft. You were part of Max Air and working on different types of lightweight ultralights, and then, of course, your own designs, and now you're working on this RV-9 with the Rotax 916. Out of all of those, is there one that you just always want to fly if it's just for you?
Well, if it's just for me and it's just for fun, the AirCam, I always enjoy. I just never get tired of being in the front seat of an AirCam on a nice day, flying low, even by myself. That's a special ride. So yeah, and if I'm trying to get somewhere in a hurry, that I'll grab that RV-9 and boom.
And go somewhere very, very fast.
Yep. And on, you don't even think about the fuel. You're going to use so little fuel, it's just not even a factor. Right? Versus we have a Piper Lance, and when you go somewhere long distance in that, you think about the fuel. 94 gallons. you notice that on your credit card when you fill it up with avgas. But in the RV, it's nothing. It burns nothing. It's amazing.
That is amazing. I can't wait to start seeing those and hopefully get a lift in one of them and see what it's like to fly it. All right, question number two. During all of this flying experience that you've had, was there a particularly impactful or perhaps scary or other moment in your life that you learned something from that really kind of changed your outlook on things?
Yeah, quite a few. Actually, there were quite a few moments that I remember. We were flying in the Congo, and we did a midday mission and didn't take the GPSs along, and it was all rainforest with no contrast to the trees. And got out over the Ndoki River, and Nick Nichols was taking pictures, and it was getting dark. It was actually towards the end of the day, and I told him we got to go back. I mean, the airstrip's not lit. and we've got to turn back. It's just a couple more pictures, just a couple more pictures. And finally, I got him, convinced him, we got to go. We're going. So we turned back, and as the sun was setting, there was a logging road that we were following, because the trees that had grown in where they took the trees out for the road were different green. And so you could see those trees on top of the canopy, and that's how you could find your way back to the base camp and where the runway was. And that disappeared, and we could not see the road. And so we're headed back to the Nindoki River, or the Songa River, where the airstrip was from the Nindoki River, and we lost the road, and if we hit the river and turn the wrong way, we would be done, because it was just about dark. We would never find the strip. And so I turned about 5 degrees left of the course that I knew should take me there, and followed that heading. Couldn't see much of anything but just trees. And then we hit the river. I turned right, and short distance there was the runway, and we landed, and it was like just the tiniest bit of light left. So that was a kind of a learning lesson.
Wow. Well, definitely something to learn from that.
Yeah, don't push it. If you're going into an airstrip that's not lit, don't push it, and you might not be that lucky.
Yeah. Well, we're certainly glad that you did turn the right way and that you are with us tonight. Okay, question number 3. If you could go back in time and just really experience some wonderful memory or wonderful moment of your life for, 15, 20 minutes, just not to change it, just to be there, what is it of your flying? Where would you go back to?
Probably flying in Namibia. I mean, that was pretty cool. But I gotta say, I mean, flying out in Utah, some of the AirCam flying I've done in Utah, some of the AirCam flying I've done in the Bahamas, that's as good as it gets. I mean, I look at the pictures, and we go back pretty regularly. We're going to do another AirCam fly out to Utah in September of 26, and we're starting to plan it already. That's probably some of the best flying I've ever done.
Wow, that is wonderful. Okay, question number 4. If you could go back and give advice to your younger self in your teens or your 20s, what would you say?
Wow. It's like Groundhog Day. Yeah. Wow. I probably would have studied harder in school. It's like to kind of figure, instead of just having too much fun. I would have liked to have seen what I could have done. But yeah, I don't think I would change too much. I mean, I've been pretty lucky. I've had a great life, enjoyed what I've done. So yeah, I that's a tough one.
A life well lived requires little advice to your younger self. That is perfect. All right, last question. Question number 5 of SocialFlight's Fast 5. If you could choose anyone, alive or no longer with us, someone from history, someone present, anyone at all to spend an evening with, who would come to mind?
Well, it would be some of my best friends, and some of my family members. For me, I'm happiest, and I've come to realize this, when I am in a place that I like with the people that I like best. And so for me, that's usually my family, my brothers, and my wife, my kids in particular. Done a lot of cool stuff with Ian. That's him in one of those pictures. Flew out to Telluride with him, and in a place that I really like. So that is for sure when life is at its best for me.
That's absolutely perfect. Well, Phil Lockwood, thank you so, so much for taking time out of your evening to join us here on Social Flight Live. It has really, really been a pleasure to spend the evening with you.
Thank you very much.
And for everyone out there, if you could just give the website for to find Lockwood Aviation.
Lockwood.aero is the main website. If you want to find out about the 916 conversion, go to RV916.com. Pretty easy, pretty catchy. And then aircam.com is for the AirCam. So
absolutely. Fantastic. Well, again, thank you so, so much for taking time out of your evening to join us here, and I look forward to seeing you again soon.
My pleasure, Jeff. Thank you very much for inviting me on.
All right. Take care. Good night.
Good night.
And thank all of you for taking time out of your evening to join us here on Social Flight Live. We'll be back next Tuesday that is January 28th with Scott Cartvet, the Blue Angels pilot, fighter pilot, and author of Full Throttle. He is an absolutely amazing individual. Can't wait to share his stories with you, and boy, does he have stories. So please join us again next Tuesday evening here on Social Flight Live. Until next time, I'm Jeff Simon for Social Flight, and I wish you all blue skies.